So 4, 5, and 6. A and B on each of these questions is really asking you the same stuff that was on that worksheet that we just graded yesterday. Okay? So it's asking you what's the domain, what's the range. It's asking you in backwards order though, so don't let that freak you out. So this is asking you first for the range, which is up and down, right? It's on the y-axis. You're right. Because if I build those walls above and below, eventually my graph's going to hit it, right?
What happens when the line has to stop?
What's that?
What happens when the line has to stop, eventually?
Well, the arrow means it never stops.
It has to stop.
But it never does.
It's infinity on
It can go on.
That is what, theoretically, this arrow means that it goes on forever. Okay? So the range is all real numbers. Guys, can you? Thank you. How about the domain?
All real numbers.
Good. Because same thing, if I went left to right on that graph, it would eventually hit, no matter where even if I put those out there, it would hit. So all real numbers there. You know, let's just go through and do A and B on each of these questions, and then we'll come and talk about what the part C's are talking about. Okay? So what did you put for the range for number 5?
All real numbers except for the negative.
Okay, so, and does this actually hit 0? No, it gets really close to 0, but doesn't actually hit it. So I would say all real numbers above 0. Saying positive numbers is an okay way to say that too. All real numbers above 0, but notice I'm not using the equal sign there because I don't want to include 0. I don't want to let it touch 0. You could also write it like this, all real positive numbers. Either one of those. Yep, that'd be perfect. I guess if you wanted to. It's more than you need, but sure. What about the domain?
Same thing.
Almost.
Almost not.
Because this is saying it's numbers above 0 only. But as far as the domain goes, when I'm talking left and right, all of this is negative. So it does hit negative numbers here. All real numbers except just 0, right? Because it doesn't hit 0 in the middle, it doesn't hit this. So I'm going to say all reals except 0. Okay. And number 6. What do we have for range on number 6?
All real numbers except for like the negative one.
Okay, except these are negatives, right? It does hit some of the negatives.
Only 3.
Okay, so how would we write that if we wanted to say it only goes down to 3? Or to negative
All
3?
real numbers and then that one sign.
That one sign. Okay.
It's like
There we go. Okay, I was going to ask you, greater than or less than are really your two choices here. We want it to start here and go up. We want to say everything above negative 3. So I'm going to say greater than or equal to negative 3. What do we say for domain on that one? All real numbers, good, because if I built the walls left and right, it's going to eventually hit them. So all real numbers here. Okay, on a graph, this function notation is a little confusing. So let me just tell you this, that f of x is exactly the same as y. Oh, you can't see what I'm writing. F of x and y are sort of interchangeable. So you might see a graph written as f of x equals blah, blah, blah. Or you might see a graph that says y equals blah, blah, blah. Okay? So here, when this says for what values of x is f of x equal to 0, that's really saying for what values of x is y equal to 0. Well, if I look on this graph, here's where y is equal to 0. What's x equal to right at that point? 0, yeah. So it's when x equals 0. And so what you're really saying here is that when x equals 0, y equals 0. Okay? Find g of negative 2. Do you remember how to do that off of a graph? Okay. Think back to the front for a minute. And my front is not filled in. But here where I wanted you to find c of 1987. Somebody raise your hand and tell me what you would do to find c of 1987. Go ahead, Austin.
You would look at 87 and then go up.
Okay, and you'd go up, and then you would...
Stop.
How would you get your information from that dot? Like what number?
Well, you kind of estimate.
From across, right? You would go across to the y, and you would say what number does it hit over here?
67.2.
Okay, that's the same thing we're going to do here. G of negative 2 means to find -2 on the x-axis, which is like right here, go up to the graph, and then read across and tell me what y value that's at.
That's at 2.
That's at 2, yep. So we would say y equals 2. Okay. And then for what values of x is f of x equal to 1? Well, remember we can say f of x, really that's like y equals. So when does y equal 1? This one's a little
It
trickier.
doesn't equal 1.
Well, let's look at this. Here's where y is equal to 1, right? But it's equal to 1 all the way across here. This is all y equals 1. Okay?
So it's 2.
So
1.
4, Curtis, can you say what you said again?
4
4 and
and -4.
-4, yeah, this one happens
Good job,
twice.
Curtis. Good job.
So
Good
it's equal to 1 at 4, and it's equal to 1 at -4. And if I was writing this like in one of those bubbles, you know, the bubbles for the function notation, here's what would happen. I would have 4 and -4 over here in this bubble, and they would both be mapped up to 1 over here. Is that okay as far as the
Yeah.
function goes?
Mhm.
Yeah, that is still a function. So that's just what that would look like. You good on those now? All right.